Okay, so we have question 4. It says given f of x is equal to 2 over x plus 1 minus 3. 4.1.1 says calculate the coordinates of the y-intercept of f. So we know for the y-intercept we have to make x 0, right? So let's go. We have f of x is equals to 2 over x plus 1 minus 3. But remember, we are looking for the for the y-intercept, so we make x 0. So this is 2 over 0 plus 1 minus 3. If you punch all this in a calculator, it gives you negative 1. So our coordinates are 0 is to negative 1. 4.1.2 says calculate the coordinates of the x-intercept of f. So we know for the x-intercept we make y 0 or f of x 0. Remember, f of x and y, it's all the same thing. Then we have f of x is equals to 2 over x plus 1 minus 3. Then f of x is 0 is equals to 2 over x plus 1 minus 3. Transpose that negative 3 to the left hand side. Then this is 2 over x plus 1. We can cross multiply here. This will be 3x plus 3 is equals to 2. Then this is 3x. Take this 3 to the right hand side. This will give us 2 minus 3, negative 1. Then divide by 3, divide by 3. X is equals to negative 1 over 3. Then our coordinates are negative 1 over 3 is to 0. 4.1.3 says sketch the graph of f in your answer book, showing clearly the asymptotes and the intercept with the axis. We already have the intercept with the axis from calculating the two questions, 4.1.1 and 4.1.2. But then how do we now indicate the asymptotes? For the asymptote, the vertical asymptote, we go x plus 1 is equals to 0. Then it's going to be x is equals to negative 1. This will be the vertical asymptote. Then the horizontal asymptote, we know it will be represented by this constant here. So this is y is equals to negative 3. Now remember, what I told you is that every time you want to draw your hyperbola graph, it is best to start with the asymptotes. So let's draw our Cartesian plane like that. Then we have the vertical asymptote is negative 1. So it goes here. Then indicate here, this is x is equals to negative 1. So we have negative 1 here. Then our vertical asymptote is 3. So it will be found below here. Y is equals to negative 3. So this is negative 3. Now coming to our intercept, we have the y-intercept 0 is to negative 1. So it will be here. Indicate 0 is to negative 1. And then we also have the other one, negative 1 over 3. So which gives you something like 0.33. So it should be somewhere here. That's negative 1 over 3 is to 0. Now if you join these 2 points, they must give you the curve here. So joining these 2 points, you will have curve nicely like that. So it shouldn't touch the asymptote. Then obviously the other one, you should have it here. So A is positive. It's in the first and the third quadrant. So that's how you have your sketch like that. So you have clearly indicated the intercept and you have clearly indicated the asymptote. Then you can just label this is f of x. 4.1.4 says one of the axes of symmetry of f is a decreasing function. Write down the equation of the axis of symmetry. Now when they say decreasing function, this is another way to say it has a negative gradient. Remember, if something has a negative gradient, it will be a decreasing straight line, right? So a straight line that has a negative gradient, it is a decreasing function. A straight line that has a positive gradient, it is an increasing function. So remember, this is how we go about it. We just take this and then put -1 in front here. So solving 4.1.4, we have negative x plus 1 minus 3. Then we say y is equals to that. Then this is y is equals to negative x. If we multiply inside here, -1 minus 3. Then we have y is equals to negative x minus 4. So this becomes our equation for the axis of symmetry, which is a decreasing function. 4.2 says the graph of an increasing exponential function with equation f of x is equals to a b to the exponent of x plus q has the following properties. The range, we are told that the range is y greater than -3. Now we know the range of an exponential graph is always y greater than the asymptote, right? So y greater than the asymptote. So -3 here is the asymptote, meaning the graph starts all the way from above -3, which now indicates our q here. Then the points 0 is to -2 and 1 is to -1 lie on the graph of f. Now 4.2.1 says determine the equation that defines f, but we already have q. The q is represented by this here. So remember, q is our asymptote, and this is saying y greater than the asymptote. So q is -3 straight away. Now we can use this coordinate to find a and b. Now if we want to find for example a, we can use this coordinate here. 0 is to -2. So we have f of x is equals to a b x plus q. Now we have the coordinate 0 is to -2, right? So that means we have to substitute -2 where there is f of x, and then here we have a, and then b, where there is x, we substitute this 0. But what is q? Our q is -3. Now solving this, we have -2 plus 3 is equals to any number to the exponent of 0 or any alphabet to the exponent of 0 is 1. So here we are left with a, because that's a times 1. Then -2 plus 3, that gives us 1. So our a is 1. Now we can use the other set of coordinates to calculate b. Now that we have a, the other set of coordinates are 1 is to -1. So 1 is to -1, and then we have f of x is equals to ab x plus q. But then remember, using these ones, we have -1 here, and then our a we have already calculated. This is 1, and then b here. What is our x here? It's 1. And then what is our q? It's -3. Then if we transpose that one to the left hand side, we have b, -1 plus 3, that gives us +2. So we have calculated the values of a and b. If we now have to write it in terms of the equation, this is f of x is ab x plus q. So our a is 1 and our b is 2. So we have 2 to the exponent of x minus 3. This now becomes our equation. Okay, so now we have 4.2.2. It says describe the transformation from f of x to h of x, which is now equals to 2 times 2 to the exponent of x plus 1. So now the way to go about this one is, let's first write our equation for f of x. We found that it was 2 to the exponent of x minus 3. Now h of x is 2 to the exponent of 2 times 2 to the exponent of x plus 1. Now the way to let's write this one in a way that we want to see what is happening here. So if you check here, we have same basis, meaning that we can add the exponents. So we have 2 to the exponent of x plus 1, and then we have plus 1 here. So now we want to check what happened. What is the transformation that took place from f of x to h of x? Now looking at this, remember that whatever that we have here in the exponents represents our horizontal shift. So this is either to the left or to the right. And then whatever that we have here represents our vertical shift. So this is up or down. So from f of x, we had 2 to the exponent of x, but then now in h of x, we have 2 to the exponent of x plus 1. So remember, when it comes to the horizontal shift, if we have a plus 1, this indicates that this is being shifted to the left, right? Since we can see, if we can take that x plus 1 and equate it to 0, this is x is equals to negative 1. So this represents that from f of x to h of x, this has been shifted 1 unit to the left. Remember, to the left is in the negative direction. So from f of x, we have the horizontal shift. That means it's 1 unit to the left. 1 unit to the left. So from x to x plus 1, that's a shift 1 unit to the left. But what about this? From negative 3 now to positive 1. So this one is just a matter of, if I'm moving from negative 3 down below here, let's say this is negative 3, and then I have 0 here and 1. So this is negative 2, and that is negative 1. How many units will it take me to get to positive 1? So this is 1, 2, 3, 4. So that's a shift 4 units upward. So 1 unit to the left and 4 units upwards. So describing the transformation of f of x to h of x, we're going to say the graph was shifted 1 unit to the left and 4 units upward. So that becomes it.